Welcome back to The Explainer. Today we're looking at an absolutely monumental shift in how we interact with software. Now, I know half the internet just recently switched over to Claude, but OpenAI just dropped a massive update with their GPT-5.5 model and a really powerful new desktop agent called Codex. So the big question is, has OpenAI reclaimed the throne? Are we officially past the point where most software even needs a human to build it? Okay, let's dive into this.
Here's exactly what we're covering today. 1. The autonomous desktop era. 2. Codex versus Claude, head-to-head. 3. Building apps without manual code. 4. Why GPT 5.5 outperforms. And 5. The isolated coding exception.
All right, Section 1, the autonomous desktop era.
So OpenAI didn't just update a language model here, they shipped Codex. This is a desktop app where the AI actually rolls up its sleeves and does the work. And it has 4 completely wild new powers. First, it handles native files. We're not talking about it just giving you code snippets or screenshots. It builds live editable Excel spreadsheets. In one demo, it was building a financial waterfall analysis, noticed its own math regarding options was about to be wrong, paused, fixed its own formula, which honestly is more than I can say for myself during tax season, and just kept going. Second, app usage. Give it a 2-sentence prompt and it'll pop open Chrome, navigate to a website, read the release notes, open your Notes app, and structure a fully formatted document. No clunky API connections needed. Third is autonomous browsing. It can navigate a complex customer onboarding flow all by itself. And what's crazy here is, if a button label is missing on the website, it doesn't just crash and give up. It actually looks at the page, guesses the right option like a human would, and proceeds. And finally, image to app. You hand it a visual mock-up of a booking flow, pick the mood you want, and in that exact same session, Codex turns the image into a working, responsive application.
You see, the crucial bottleneck before Codex wasn't that AI agents weren't smart enough. It was that they couldn't reliably navigate the totally messy, fragmented reality of our computer desktops. They couldn't seamlessly hop from Chrome over to Notes and then down into Excel. Well, now they can. They're interacting with these apps exactly the way you and I do.
Moving right along, Section 2, Codex versus Claude, head-to-head.
Let's look at test number 1, analyzing a home plumbing repair video. The prompt asked for a breakdown of tools, materials, and a timestamp summary so you could skip the filler. Claude Code delivered a pretty basic, generic overview. It kind of felt like it just skimmed the video. Codex, on the other hand, it read the full description, extracted literally every single tool and material, and produced a granular second-by-second summary of the action. Total precision.
Test 2. Create clips from a podcast. The prompt asked for vertical clips, 60 seconds max. Claude Code thought about it for a bit, asked for bypass permissions, and then ultimately just handed back a text list of clip titles and timestamps. And this right here perfectly highlights the difference between chatting about work and actually doing the work. Because Codex, it delivered 6 actual MP4 video files. They were already cropped to a 9:16 vertical aspect ratio, totally formatted, and ready to hit play.
Test 3 was a design challenge. The goal was to recreate a single slide from an Apple iPhone keynote exactly, but as an HTML presentation. Claude Code gave us a layout that was close, but it felt a lot like a wireframe. It had missing images, generic fonts, you get the idea. Codex executed a near pixel-perfect recreation. It nailed that specific Apple-style typography, the exact bar charts, the sleek dark theme. Side by side, you could barely tell the difference. In the final head-to-head test, build a 3D UFO shooter game using 3.js, which is a popular web graphics library. Claude generated a game that technically functioned, but it was basically an unplayable, blocky tank with a locked camera. You couldn't even look up at the UFOs. Codex built a game with a working neon UI, aiming crosshairs, firing lasers, exploding UFOs, and actual health and score counters. So when it comes to bringing complex ideas to life on the desktop, Codex really demonstrated vastly superior execution.
Which brings us to Section 3, building apps without manual code.
We're looking at a real-world case study here, and the setup for this was shockingly simple. Step 1, write a single project brief asking for a Mac app to manage content across Instagram, YouTube, X, and a newsletter. Step 2, set a 30-minute background heartbeat and wire it up to a voice AI tool so Codex could literally call a human on the phone if it got totally stuck. Step 3, run it in full auto mode and just go to sleep.
9 hours later, wake up and check out the sheer complexity of the dashboard Codex built all by itself.
It created a live data matrix that successfully authenticated and pulled APIs across 4 different platforms for an audience of 4.3 million users. It built repurposed logic, an intelligence layer that automatically analyzed a survey of 81,000 users on X and suggested turning those insights into an Instagram reel. It integrated OpenRouter to create a Copilot analytics tab so the user could seamlessly chat with their own raw content data to spot trends. But honestly, perhaps the most impressive part, it built a highly resilient operations panel. When Meta rejected an Instagram token, Codex didn't just crash and wait for help. It spent over 2 hours autonomously driving the browser to solve the authentication issue on its own, managed the caching, and safely archived 7,700 raw API payloads. And you've got to see this specific feature integration. Codex built an entire comment response engine to manage over 7,000 comments, and it deliberately wired it to be powered by Apple Intelligence running entirely locally on the Mac. It drafted all those replies without any of that proprietary data ever leaving the laptop. It brilliantly integrated local hardware capabilities into an automated workflow completely on the fly without being explicitly handheld through the process.
I really want this to sink in for a second. 9 hours, one single project brief, an application capable of managing 5 million followers across 5 platforms, and 0 lines of manual code written by a human. For years, the promise has been that one day you'd be able to just build your own bespoke software instead of buying some rigid tool off the shelf. Well, this case study proves that day is officially here.
Okay, Section 4. Why GPT 5.5 outperforms. To give you some context, a math professor in Poland with absolutely zero coding background used this model to build a live 3D algebraic geometry app in just 11 minutes. The reason he could do that? Token efficiency. GPT 5.5 has fundamentally changed the user experience because it finally stops overthinking. It completely drops those 3 paragraphs of polite setup and context and just gives you the exact answer or the exact code block in one shot.
There are really 3 core upgrades powering this engine under the hood. First up, a massive context window. You can paste in a giant document, a totally messy research brief, or a massive codebase, and GPT 5.5 actually tracks all of it without losing the plot. Second, multi-step independence. If you give it an ambiguous 5-step task, it actually makes a judgment call and executes all 5 steps instead of stopping to ask you 10 clarifying questions. It no longer requires constant babysitting. And third, it's completely agent-ready. It's specifically optimized to be the brain behind autonomous tools like Codex.
And the data completely backs this up. On the GDP-Val benchmark, which is a really rigorous test of actual professional knowledge work across 44 different jobs, GPT 5.5 scored an 84.9%. Let that sink in. That is the highest score any AI model has ever achieved on that test, period.
Finally, Section 5, the isolated coding exception.
Now, to be completely fair, while GPT 5.5 absolutely dominates when workflows are messy, ambiguous, and require jumping between multiple tools, it is not the undisputed king of every single task out there. There is one very specific scenario where Claude still holds the crown. Check out the pure code editing benchmark. When you isolate the task to writing or editing code in a single file, Anthropic's Claude Opus 4.7 still edges out GPT 5.5. It scored a 64 against OpenAI's 58.
So, to summarize the current competitive landscape, if all you do all day is write pure code in the pristine vacuum of isolated files, Claude is still an incredibly competitive choice, maybe even your best bet. But the moment that work gets messy, the moment the model has to think across a whole system, hold massive context, integrate multiple desktop apps, make independent judgment calls, and keep moving, GPT 5.5 pulls clearly ahead.
And that leaves us with this final thought. The AI agent you choose entirely depends on the nature of your actual daily work. So look closely at your workflow tomorrow morning and ask yourself, are you just editing isolated code, or are you trying to automate a messy, multi-tool reality? Your answer to that will tell you exactly which model you need to transform how you work. Thanks for joining me on this explainer, and keep exploring.